Welcome, Mr. Anderson here, and I'm going to talk to you today about a little standard I like to call FF3, where we use graphical and algebraic structures and techniques to transform functions into equivalent forms to expose different information and identify key features. All right, let's see what this is about. Let's take a look at some questions here. Question number 1, factor and find the x-intercepts for the following function. Okay, so we have here a quadratic. It's a quadratic because we've got a square there. It's the highest degree. And we need to factor and find the x-intercepts. X-intercepts or solutions or roots or zeros. All right, we call them all sorts of different things, and they have a little bit different meaning. Well, we're basically saying the same thing. So if I was to solve this quadratic, I'd set the y equal to 0, and when y equals 0, and we solve for x, when y equals 0, those are x-intercepts. So anyways, let's factor this this quadratic here. So I need something that multiplies up to negative 40 and adds to negative 3. And I think about, okay, 40, and it's got to be a negative 40. I think factors of 40, I got 1 and 40, I got 2 and 20, I got 4 and 10 and 5 and 8. Hey, how about 5 and 8? Has to be negative 40, so I'll make that 8 negative and that 5 positive because it has to add up to be a negative 3. So I'll make that plus 5 and a minus 8. So a 5 times a negative 8, that gives me a negative 40. And 5 minus 8, that would give me negative 3. All right, so these are the factors, though. They are not the solutions or x-intercepts. All right, get the x-intercepts. I need to use the zero product property. And some of you might just think, oh, well, that's easy enough. I just take the opposites of these numbers in the factors, and that's true. I guess in this instance here, that is true. Zero product rule, we set each one of these factors equal to 0. X plus 5 equals 0, and x minus 8 equals 0. And here we'd subtract 5 to get x equal to negative 5. When y equals 0, say when y, this is our y here, when y equals 0, then x equals negative 5. And the other one, we add 8, and we have x equal to 8. So we need a negative 5 and an 8. Negative 5 and an 8, and there it is, letter B. Those are the two x-intercepts. Those are the two solutions when y equals 0. Question number 2, which of the following equations would be a step in completing the square for the equation x squared minus 8x minus 10? Okay, well, first thing I think of in completing the square, I want to move that 10 over to the other side of the equation. I just want to get it out of the way. So add 10, and I have here x squared, and I got this b term, 8x, and I moved the c term over to the other side by adding 10. The binomial that we want to square is half of this b term. All right, it's negative b over 2a, but a is just 1. So so we just have x minus 4 squared, and then this is not equal to what I just wrote above is the problem here. So I'm going to need to add something in there, and I'm going to need to add that same thing over here. And so I'll show you what I'm talking about here. X minus 4 squared, that's x minus 4 times x minus 4. And I got to distribute my x first, right? So that's x squared minus 4x. And then I've got to distribute my negative 4, right? So that's negative 4 times x. That's another negative 4x. Negative 4 times negative 4, that is plus 16, which gives me x squared minus 8x plus 16. So what I want you to notice is this is not the same as that, but I wrote this x minus 4 squared for a very important reason. Oh, I don't need this on the left side. I already have it on the left side. Let me get rid of this spot right here. Okay, so this over here has a 16 included in it. And so I need to include that on the other side of the equation here. I need to add 16 over here, right? Because I wrote x squared minus 8x plus 16. I have a plus 16 over on this side here. That's what this x minus 4 squared is. So you're like, well, why did I do that? Well, I'm essentially putting it into a vertex form or solving, right? So this is, anyways, I have x minus 4 squared equals 26. So I'm looking for that would be a step in here. And that would be letter D. Okay, I guess the gist of it here is I took half of that b and squared it, and then found what I had to add to the other side of the equation. So maybe takes a little bit of previous knowledge on your completing the square, which I'm not going to get to in depth here, but I will show you the steps that I took. I moved this number over to the other side, right? That was the first thing that I did there, and then the next thing that I did was I found out, hey, what is the number that goes right here? That was the second step I took, and I said, okay, well, that's going to be half of my b term. That looks pretty sloppy. Half of b. Half of b. I took half of my b term. So that's how I got the negative 4. But then I multiplied x minus 4 times x minus 4 in step 3 here. Step 3, I multiplied, and I found, okay, there's an extra 16 over here, and so I need to add that. I already inherently added it on the left side of the equation, so I need to add it to the right side of the equation. Okay, and that's the long and skinny of it. I'm going to move on to question number 3. All right, and really, to know more about that, you need to look up more videos on completing the square. Okay, which product of factors is equivalent to the expression 64x squared minus 48x plus 9? So, and then I've got a series of answers here, and they all have 8x as my first term in the binomial factors. And then I got a choice of 3 3's or 1 and 9. All right, well, this looks to me to be a perfect square trinomial, meaning that I can multiply those same two binomials by itself, the same factor by itself, and get the trinomial. All right, I know the 8x times the 8x is going to equal 64x squared, right? I know that the f of that FOIL, I'll get it all the way over to the 8 there. I know that's going to equal 64x squared. Now, the other side, the positive 9, let's see, 1 and negative 9, that's not positive 9, right? Negative 1 and negative 9, okay, that's positive 9. Negative 3 and positive 3, that's not a positive 9. Negative 3 and negative 3, that's a positive 9, all right? So I have 2 that are left here. So I guess it's up to the middle term here, and I'll write it out here. 8x minus 3 and 8x minus 3. Okay, what I like to call little smiley and big smiley. All right, this is your middle term. When you add together little smiley and big smiley, or you could say the inner and outer products. Here, little smileys, that's your inner product. Negative 3 times 8x is negative 24x. And then here's big smiley right here, and that's the outer product, the outer two terms. 8x times a negative 3, that's another negative 24x, and that adds up to be negative 48x. So that's what I need for my middle term. The other one, if you added up little smiley and big smiley, what do we get? We get a negative 8 and a negative 72. That's way too big for negative 48. So our answer here would be B. Okay, how about the last question here? Which equation shows the minimum or maximum value of f of x without changing the form of the equation? Well, this is actually quite simple. All of these equations look like they are the exact same quadratic equation, just in different forms. And the minimum or the maximum, think of the minimum or the maximum of a quadratic, right? So all of these are quadratics, all right, because they got the x squared. This one doesn't have the x squared, but it has an x times x, which would give us x squared right there. And in a quadratic, which if we graph it is a parabola, we know if it opens downward, right, it has the vertex right here is a maximum. That's a maximum on our y-axis, right? That's a maximum. And if it opens downward, I'll write it like that. There we go. If it opens downward, right, then that vertex is a minimum value for the parabola goes as low as that value, but the vertex is always going to be either the max or the minimum. And if we look at B right here, and that's our answer, that's in vertex form. We see that the vertex is at negative 3, 4. Negative 3, 4. And so that would also be our minimum for this parabola here, because we see it opens downward because of the negative out front, but we didn't ask us about that. First one's in standard form. The letter C, that is in intercept form, the x-intercept form, and D just has a greatest common factor factored out of it. So, all right, that's those 4 questions, and I will see you later.